with math or with any kind of a skill, you can watch somebody do it and you can understand what they're doing, but you won't be good at doing it yourself unless you actually practice, right? Like if I watch somebody make a nice cake, I'll understand what they're doing, right? People watch cooking shows all the time and it doesn't make you a good cook, right? You actually have to do it. You actually have to touch it, right? And it goes into your long-term memory then when you repeat things over and over again, right? Yeah. Like people that love sport. Yeah. You know, I know lots of like terrible athletes, like they're terrible, but they can watch a sport and they understand it and they're saying, why didn't they pass it? You watch people watching hockey, most people suck at hockey, right? But if you go to Winnipeg, you go to anywhere and people are watching Jets games, everybody's an expert, right? Because they can see it, they know what's supposed to happen, but doing it, they're like, why didn't he, you know, of course the goalie always goes down, why didn't he go up high over here? It's not that freaking easy. That's what they're trying to do, right? So, you know, it's not that easy to be able to do things unless you practice them over and over and over again, right? That's how we become good at things. We just keep doing them. Okay, so with math, it's very hard to get good at math stuff unless you're actually doing it repetitively. Okay, I'm pretty good at math. I'm kind of lazy, but I'm pretty good at math because I've done, by now, probably hundreds of thousands of questions. And if I do something repetitively, I master it very quickly. Most people with math stuff, they want to do as little as they can, right? Just to get it over with, right? Just I never want to do this again. But it's hard to get good at it. Okay, so hopefully you're doing the questions.
You use math every day.
Well, I do. I'm a math teacher, right?
Yeah, except like money.
Yeah, some stuff, money. Like people are pretty good with math stuff related to money because they use it all the time, right?
Fixing things and using math.
Well, you can. Yeah, should. Okay, find the area. Yeah, like carpenters are really good at like visualizing, like estimating. They're really, really good at doing addition and subtraction because like they're always measuring, trying to figure out parts, and because they use it, right? My father-in-law was a chef. He's fantastic at fractions. Almost nobody's good at fractions, but chefs are great at it because they're constantly working with it, right? Find the area of the following figures. So this one's like, it's just length times width. They're both the same units, so you don't have to worry about that. So you're just going to go 4 times 10.25, which is 41. And what's the units? Centimeters squared. Or you could say square centimeters. Okay. When you see the little 2 there, it means you're dealing with an area. If you see a 3, what are you dealing with? It's cubic, yeah. And what do we use cubic for? Describing what? Volume, yeah. Which is the next lesson. So, this one, if we're finding the area, well, we need to know the formula. The area of a circle is pi r squared. I don't have the r there, the radius. What do I have? What is this? That's a diameter, right? That's more than I need. That's twice as much as I need, right? So if I'm going to turn that into a radius, that would be a radius. How much is it? Yeah, it's half that. So 4.25 centimeters. That's what I want. Half the diameter is the radius. So step 1 is to cut that diameter in half. Then I can use this. Pi, which is a button on your calculator, 4.25 squared. So I have a pi button. You might have to use a shift or a second to get yours. There's the pi times 4.25. And if you have an x squared button, you can use it. I don't see one on mine, so I'm just going to use the exponent key squared equals. And I got 56.7 square centimeters. What's that? You got 75?
Yeah, 6.
Oh, if you round it to 2, yeah. Yeah, I just rounded it to 1. Yeah, if you want to be more accurate, the more of those extra numbers you have, the more accurate you are. So, is that what they put in the back? 2 decimals? Oh, okay. if it doesn't say, it doesn't really matter. Normally, especially, they're really particular about that stuff on the provincial exam for the Essential 40 that you'll all be doing. But they'll tell you. It'll always say round to 1 decimal or 2 decimals, so you don't have to guess, okay? This one, the triangle, it's base times height, and then divide that by 2. 4 times 3.2 and divide that by 2. Looks like 6.4. 6.4 square centimeters. All right, the next one is a square, which is the same thing. A square is actually a special kind of rectangle. What's special about it? Yeah, all the sides are the same. Yeah. Or all the angles are the same, right? The 4 90-degree angles. So a square is just a special rectangle. So yeah, it's just 3 times 3, which is 9 square centimeters. This one is already given to us as a radius, not a diameter, so we don't have to change that one. I'm just going to go pi times 6 squared, which is 36 pi. Pi times 6 squared. 113.1, or if we do it to 2, I guess, 0.110. Is that what they put? Okay. And this time it would be meters squared, m squared. This one is base times. Okay. So 85.5 kilometers squared. Is that what you got? Okay. Bless you. Now this one here, this is one of those ones where you can cut it into 2 pieces. It's probably, so you can either cut it like as a long rectangle, or you can cut it here. First of all, let's fill in what we know. This is 12 kilometers, and these 2 ticks mean they're the same length, so they both have to be 6 then, right? 6 kilometers, 6 kilometers. So I could go 6 times 50 to get that. Yeah, that's the way I'm going to do it. So I'm just going to cut that there. Then this rectangle here is 50 times 6, which is 300 square kilometers for that piece, this piece here. This one is 20 times 6. Okay, ignore that 12 there. 20 times 6, which is 120. So if I add them together, you should get 420. Is that what you got? Okay. You could have cut it the other way, right? You could have gone 20 times 12, which is 240. And then this piece here, you would have had to say 50 subtract 20. That'd be 30 times 6. So it'd be 180 plus the 240 from there, which makes 420. It works either way. Okay, this one, I'm going to redraw that as a rectangle, a sketch over there, and a circle. And if I find those 2 areas and add them together, then I'm good. This is 200, and this is 80. So 200 times 80. I got 3 zeros. 1, 2, 3. And 8 times 2 is 16. So that's 16,000 square meters. And this, the diameter was 80. So what's the radius then?
40.
Yeah, 40. The radius is 40. So then I'm going to use that area equals pi r squared. Pi times 40 squared. It's going to be a pretty big number. Pi times 40. 5,026.55 meters squared. Okay, so the total area then is going to be 16,000 plus 5,026.55 meters squared. Did you get something like 21,026.55 meters squared or something close to that? Did anybody check the answer in the back?
Yeah.
No, that's the answer.
It's all in your head, right, Aaron? Yeah. Check it. Simon Chu.
That's what I need.
Ah, there it is. 21,026.55, which is exactly what I wrote, which means the answer in the back is correct.
They're all correct.
If I do it and the answer in the back matches it, then I know the answer in the back's correct. If I do it and the answer in the back's wrong, it tells me there's something wrong with that answer. Or maybe I made a mistake. Deliberately, just to see if you're paying attention. Okay. Okay. Page 8, number 2. Find the area of the shaded part. So we do the area, and then we subtract out the thing in the middle. So when I look at that, I basically want to find the area of the square, and I want to subtract the circle. Okay. So the area of the square, we're just going to put a square, is 8 times 8, right? So that's 64 square centimeters. And I'm going to subtract the area of the circle, which is pi times... Okay, if it's 8 all the way across, how far is the radius? 4. Yeah. 4 squared. So pi times 4 squared. 50.27 I'll use. So if I go 64 minus 50.27, I'll get, so the area of the shaded part is 13.73 square centimeters. Did you get something close to that? Okay.
I can do it so
Then you say, I would have if I would have done it. Yep. Okay. So this one here, so the area of the circle is pi times r squared. Oops. Pi, now the r this time, oh wait, it's right there. R equals 12. So 12 squared. Pi times 12 squared, which is 452.39 square centimeters. And we're going to subtract the area of the square, which is, it looks like it's 10 by 10. So it's 10 by 10, which is 100. So if I take 452, so area of the shaded, 452.39 minus 100, 352.39 square centimeters. Anybody got something close to that? 352.39? Does the back match that? Yeah, there it is. 352.39. Yeah, take it. It's probably better to do these questions on a separate sheet of paper. There's not a lot of space there, but I'm too lazy to actually find another piece of paper, so I'm just going to do it here. I mean, I'm not lazy. That way I can guarantee it fits into the camera. That's fine. Okay. Okay, this one is interesting. C. Because I don't know that it's necessarily... There's a couple different ways you could do it. So we could find the area of the whole thing and subtract out that triangle. That would be one way to do it.
What about
Or,
a rectangle?
yeah, we could find the area of the rectangle and then add this little triangle there to
Yeah.
find the whole thing and then subtract this triangle. But with this one, I think I might be able to just add those two shaded pieces together. Like if I do this part's okay because it's 15 times 8, right? So this one would be like 15 times 8, base times height, and then divided by 2. So this piece looks like it's 60 just for this part, the triangle here. This triangle here, I need to know the base and the height. The base is 8. This is 8 from there to there. But I need to know how far this is. Can I figure that out?
Would be 3.
Yeah, you're right. Because look, from here to here is 15. And from here to here is 12. So 15 subtract 12 makes 3. And that's what the height is. So this one, it's going to be 8 times 3 divided by 2 for that triangle, which is 12. So the two things together, the two parts, is going to be 60 plus 12, which is 72. And I think the answer is wrong in the back here. Let's go look for it. They're saying, yeah, they said 108. That's wrong. Did anybody else get this amount? Oh wait, I made a mistake. When I was doing this triangle here, I mean, I did it deliberately to see if you would catch it.
Oh, it's not.
It's not 15.
Yeah.
From there to there is only 12. 12 times 8 divided by 2, which is 48. So this triangle is 48. This one is 12.
So 48.
So 48 plus 12 equals 60 meters squared, which is still different than the answer in the back, but I am confident that that is the correct answer. And I know what they did in the back. The answer in the back is 108, which is what happens if you also added this piece, because that's another 48 there. So what they did is they did the area of the whole thing without subtracting this piece. So whoever did the key very quickly looked at the question and said, oh, the area of the whole thing is 108, and they forgot the question was just the shaded part. So 48 for there, 12 for there, 60 total. Okay. D. So this one's interesting because you got 4 circles there. So what I'm looking for, the area of the shaded part is going to be the area of the square minus 4 area, like 4 circular areas, 4 of them. So the square is okay, it's 6 by 6, right? 36 minus 4. Now the area of the circle is going to be pi r squared. The tricky part is finding that r. If it's 6 all the way across, how many radiuses would that have been? How many radiuses to get all the way across? 1, 2, 3, 4. So if it's 6 all the way across, if I cut that 4 times, half of 6 is 3 and half of 3 is 1.5. So the first important thing you had to figure out here is that R equals 1.5 centimeters, each of those radiuses. So that's the number that has to go here.
So 1.8.
So let's do pi times 1.5 squared. So each of those little circles has an area of 7. Let's say 0.07. If I multiply that by 4, I'll get 28.28. And if I do 36, which is the whole square, minus 28.28, I'll get 7.72 square centimeters. And I'm going to go see how close that is to what they put in the back there. I'll come back in a second. Oh, they use 7.73. I'll forgive them for being 0.01 off of what I have. Well, this one I'm just going to change here. Yeah, so there you go. That was kind of a tricky one, right? The hard part was figuring out that, what the radius was. And with a lot of the circle questions, that's usually the first thing you have to do is solve for R, figure out what it is. So 36 for the whole thing, and each of these is 7.07. And then you have to subtract 4 of them out. Okay, and the last one, I don't like this diagram. Does anybody know what these things are called? If you have a window that has these little bars in them, does anyone know what those are called? I'm asking you, I don't remember.
I'm just thinking cross window.
I don't know, I'm thinking like Muntin panes or something like that. It's going to drive me crazy. I have to look it up. I apologize. Yeah, it is called a muntin. A muntin, well, there's other names for it. A glazing bar or sash bar is a strip of wood or metal separating and holding panes of glass in a window. Man, I could have won Jeopardy with that. What are the little bars called that hold? Okay, muntin pane. All right, so I don't like this diagram, this picture, because it's misleading in that you think that you have to subtract off these little things. You don't, okay? Just think of it as a big open window, and it's 1 by 1, all right? You don't have to, there's nothing to be painted in here, okay? It's part of the window itself. So they really should have just used, squares. It would have been easier to look at. Anybody think they had to subtract 8 of these little things? Because that would make it confusing, so. I mean, it would still work, I guess. But okay, so this wall is going to be painted. So we're just going to find the shaded area. So the area of the rectangle, or the whole wall, is going to be 8 by 3.5, right? Which is what, 28? And we're going to subtract out the windows. So area of a window, it's just 1 by 1 for a window. 1 times 1, which is 1. Okay, so area to be painted is going to be your 28 for the whole wall, minus 1 for that window, minus 1 for that other window. So you get 26 square meters of paint needed. Anybody else get 26? Okay, and then the final question is how many cans of paint will you need to purchase if each can of paint covers 10 meters squared? Okay, so 26 divided by 10. 26 is the total area. 10 is the area per can.
2.6.
You get 2.6 cans of paint. Can you purchase 2.6 cans of paint?
Yeah.
No. No.
I thought they give you a little can.
Well, you can do that on your own. You can say, I need 2 big cans, and I need one of these small cans or whatever. But if in this question, they only mention the big cans. So you're going to have to buy how many cans? 3, right? You're going to have to go up. So we need to buy 3 cans of paint.
It ain't gonna be cheap.
It ain't going to be cheap. How much is a can of paint? Yeah, it's not cheap. Good paint. I mean, if you're gonna buy paint, buy good paint.
One that doesn't peel or.
Exactly. Don't buy cheap stuff. But a can of paint, like, and you should use a good primer. I learned that lesson with painting. Don't buy cheap primer. Like, if you're gonna, you can get away with cheap paint if you use really good primer that goes over everything and makes it nice and thick. It's like $40 a can sometimes.
Depends on where you get it.
Depends on the quality,
Yeah.
right?
As I said, $20 or $30.
Tired the other day, there's some for like $30, $40.
Yeah, for the better stuff, right?
Yeah.
You know what? If you're gonna do it, like, how often do you paint? If you're someone that likes to repaint your room every month, buy cheap paint. Most people paint like every zillion years, so buy good paint. My house is made out of cedar shakes, like the whole house. If you know what cedar shakes look like? My whole house is made of cedar shakes. What a pain for painting. I mean, the shakes are from 1912, so they last. But the painting job is very difficult because it's not a smooth surface. So, years ago I hired a buddy of mine who's like a carpenter, and to paint my house took him like a month. And I think it cost a couple $1,000 in paint.
You're thinking he kind of had a grudge on you?
Oh, he's great. Did a great job.
After he painted your house for a month?
Yeah, you know what? I couldn't have done it. I would have lost my mind. But he did a great job.
That's good.
And he sealed up all the windows and stuff. And it looks good. I have a big yellow house now. It's good.
Why yellow?
That's a good question. One I'll let my wife answer.
You just follow what you like.
Yeah, pretty much. I mean, that's the key to marriage, right?
Not really.
Get up in the morning and wait for instruction. Don't have to make decisions. Just kidding. I'm pretty sure she's not going to watch this video, so I'm good.
Oh, you're not recording anymore.
Really?
Yeah.
No, it says I'm on the air. Yeah. So if you see my wife, don't tell her not to watch like at the 21-minute mark of the.
Just keep it the
Or when she does watch that part, she will just cut off the sound and say, "Oh, look at that sound."
Oh yeah, the computer just blew up. Oh, I dropped a can of paint on it. Okay. Okay, so that brings us to volume. It's the same thing. Volume formulas are hard to remember. You do not have to memorize any formulas in this unit. You just have to know which ones to use and how to use them. Okay? And sometimes, just like these last couple questions here, sometimes there's some extra work to be done. Like this part needs to be subtracted. This one's not there. So sometimes there's a bit of...
This is the one where we do a 3.
So you're solving some problems using these formulas as well.
How would I do this, like, to check?
Right, so if we wanted to find the volume of a can, we can do it. We've got a ruler.
Yeah, hold on.
So this, anybody know what this basic shape is called?
Here, go to, or do you want to see?
Roughly, okay, it's basically a circle that's been stretched out. Think of it as a whole bunch of circles stacked up, right? That's really a good way of thinking about volume. Volume is simply like area stacked up or stretched out. So a circle that's been like, if you think of little circular discs and you just keep piling them on, eventually you get a 3D shape. And we call that, does anyone know what it's called? This kind of shape? Any cans, those kind of things. No, it's called a cylinder. Right? So it's called a cylinder, and any shape that, like this is not a perfect, like a Coke can is, cola can, is not a perfect, it's not a perfect cylinder. Because you see it's got like a little bit of a curve there and stuff. So we would say that it's cylindrical in shape. It's a really fancy word. So there are lots of things that you can see that are cylindrical in shape. But let's assume, for the sake of trying this, that it's a perfect cylinder. If I wanted to find the volume of that, I would just find the area of the circle, right? Which we know how to do, right? Pi r squared. And I would just multiply that by how much it's stretched out, which is the height.
Would that also go for his Tim Hortons cup too? Or?
Yeah, so Tim Hortons cup, again, it's a little wide, it's a little like wider at the top than at the bottom. The diameter is a little bit bigger, so we would say it's cylindrical. But it's not a perfect cylinder. It would actually be harder to measure that one and estimate it than it is for this one. So all I would do is I would just measure, it's pretty hard to measure a radius. It's a lot easier to do the diameter and then cut it in half. So if I was doing the diameter, it looks like it's around 6.5. Oh, I don't want to use inches, I want to use centimeters. There we go.
Oops.
So if I'm using centimeters, well, I guess those were centimeters. It is 6.5, roughly 6.5 centimeters. Okay, so I would write that down, 6.5 centimeters. And then I would cut it in half for the radius, which is 3.25. Anybody want to sketch that down? 3.25. So we're doing a standard, this is a standard drink can, right? So 3.25 centimeters. And I would assume that they all come from the same factories, and they just put different labels on them. So I'd assume they're all that. Okay, 3.25 for this standard size can. And then I would measure how high it is. It's around 12. It's not exact. It's around 12. So let's say it's around 12 centimeters high. 12 centimeters high. Okay, so using that, I'm going to see the volume of this can. So the circle part, the top or the bottom, so the circle or the top would be pi r squared, which would be pi times 3.25 squared. Which is roughly 33.2 square centimeters. And then that circle's been stretched up by, so the volume then of this cylinder, or the can, would be that 33.2 times 12. So times 12, which gives me 398 cubic centimeters. And a cubic centimeter is the same thing as a milliliter. Milliliter is a liquid measure, whereas this is like for lengths and stuff. So the can actually, by law, it actually lists its capacity. The word capacity means how much fits inside it. And it says 355. Any idea why it's lower than my 398? it's a fair amount lower, right? Any idea why the 355 on the can is lower than the calculated 398? There's a few reasons.
So it does spill.
Is it the quality of inside the can?
Yeah, so part of it is that when you open a can, what do you hear? You hear a sound, right? What is that sound?
It's air.
It's air.
It's like opening the baked potato chip.
Yeah.
It's like it's full, but it's actually just halfway eaten.
Yeah, the potato chip bag is the worst, right?
Yeah.
So these cans all have some air in them. So when I calculated the capacity of the can, that included the air. But when they list the 355, that is the liquid. So the can actually fits more than 355. So that's part of the reason that my calculation was higher. Another reason is that I suck at measuring, okay? And using a ruler is actually not, there's better tools for doing really good measurements, like things called calipers and stuff where I can actually clamp it on and fine tune it, and digitally it'll give me a really accurate readout. Also, it's not a perfect cylinder, right? So when I measured it, there's some dead, like I measured it as though the top here was just as wide as the sides. So, but not bad, like not that far off. But that's basically how a cylinder works. And so the same concept of volume applies to every 3D shape. If you can recognize the shape that is on one side, right? For example, like a triangle. Does anybody know what a triangle stretched out is? What it's called?
Back to kindergarten.
So it's just called a triangular prism. Prism being like a stretched out triangle. So the same idea, if you can measure the area, which is pretty basic for squares and rectangles and triangles and circles, then the volume is just that, the area, multiplied by how kind of stretched out it is. So that's a good way to think about it. It's a lot easier than memorizing a bunch of formulas. Right? You can visually kind of figure it out. And for something that's a really weird shape, if you needed to measure, I'm not sure what real life situation you need to measure how much fits inside of it, but same idea, you could chop it up into saying, oh, this looks like it's partly a circle, it's partly a rectangle, and you can chop it up and then multiply by its depth or height or whatever. And you'd get pretty close. Right? You ever have jelly bean contests where it says how many jelly beans fit in there? Yeah. They always piss me off because I just want to get a hold of one jelly bean. Right? But you're not allowed to reach in and pull them out. But because I can very quickly, because they're usually in a jar, right? And a jar is a cylinder. So I can usually estimate pretty well the height of the jar and the diameter, so that I can go grab my calculator and I can figure out how big the jar is. So if the contest was how much water is in this jar, I could win it like pretty much every time, right? The problem is freaking jelly beans, and jelly beans, like they always have air, and I need to know the actual volume of each jelly bean. If I knew that, I could figure out how many fit inside it.
Yeah, but some jelly beans are wonky and small and long.
Well, there's that too. Yeah.
So
I'd probably still lose, but I get close every time, right? Math will get you close. Okay, so.
Use your math for that.
Yeah. I always think I can win that, I never do. Yeah. Usually because I'm poor at estimating the size. Okay.
A lot of jelly beans.
No, they have a separate size, and you can get the jelly beans.
So this shape here is different. This is called a cone. You know, just like ice cream cone. Something that has this kind of shape, like some kind of hats, we say that they are conical in shape.
Are you talking about a dunce hat?
Yeah, like dunce cap. It's conical. They may not be a perfect cone, but it looks cone-esque. So there's a whole page of formulas here to look at. Now, here's the one we just did, the cylinder. Notice how it's pi r squared, which is the circle, times the height. That's what happened there. Something like a cone, notice the cone is basically the same thing as the cylinder, but with 1/3 in front of it. So it just so happens that like 3 cones put together would make the volume of a cylinder with the same circle. You don't have to memorize any of these formulas. They're in the book, and when you do your test, I will give them to you. So you just have to know how to use them. It's not bad, okay? Remember, here's what I was talking about with a prism. So a rectangular prism is just a rectangle stretched out. Okay? Think of it as a bunch of pieces of paper and rectangles, and they just got stacked, right? There you go. This is a rectangular prism. It's not very deep. But if I measured the area of this piece and I multiplied by how thick it is, I would have the volume of this shape. Okay? Length times width, then multiplied by another dimension. So for volumes, we're using three things get multiplied, basically. 3 dimensions. So for this one, you just look up the formula for all these questions. It says 1/3 pi r squared h. You write it down. And then you have to be very careful about how you punch it into your calculator. If I'm punching this into my calculator, I might just go 1 divided by 3 times pi times, and the radius in this question was 6, so I'd put 6. If you have an x squared key, that would be your next key. I don't have that, so for me I'm going to have to use the yx key. 2 times, and the h is 9, and equals. So those are the exact buttons I'll have to hit on my calculator. Yours might be slightly different. So 1 divided by 3 times pi times 6yx2 times 9 equals 339.3, and this time centimeters to what exponent? Volume's always to the 3. Yeah. Because I've multiplied 3 dimensions. I've multiplied 2 radiuses and a height. So radius times height. So there's 3 dimensions there. So cubic. So be very, very careful with your calculator work. Okay? You'll get that's why you want to have your own calculator and use it repetitively so that you get good at it. Example 2, volume of a cylinder. We just did this. This is a juice can. So this was the pi r squared h1. Pi, your radius is 4, and your h is 23. So it's just calculator work. Pi times 4 squared times 23 equals 1,156.1 cubic centimeters. So once you get to 1,000 cubic centimeters, that's the same thing if you're talking liquid measure as 1,000 milliliters. Anybody know what that's called when you get 1,000 milliliters? When you buy stuff from the grocery store? They won't say 1,000 milliliters, they'll say 1 liter. Yeah. So this can is roughly a 1 liter can. So it's a bigger one, right? It's a bigger can. It's not a tiny one, it's a bigger one. Okay, I think that's as far as we'll go today. We can slowly do more examples tomorrow, and I'll give you more time to work on it. But if you're able to, you can start doing some of the questions. Okay? They're kind of fun. I kind of like punching a bunch of buttons into a calculator and seeing if I get the right answer. But that's me.